Hello, and welcome to SETI Live. I'm your host, Beth Johnson, Communications Specialist here at the SETI Institute. Thank you for joining us today. Thank you to all our viewers who are jumping in. Let us know where you are watching from. And welcome to listeners on the podcast version of SETI Live, available on most podcast platforms. Today, I have the privilege of being joined by Kelsey Johnson, author of brand new book. This came out last week. Into the Unknown. And yes, if your brain wanders off into Frozen 2 like mine does, yeah, I have the same thing going. So I'm right there with you, everybody. Kelsey, thank you for joining us today, and welcome to SETI Live. How are you, and where are you joining us from?
Oh, it's so great to be here, Beth. I am in Charlottesville, Virginia, planet Earth.
Planet Earth. Always good to know. So you've survived all of the storms and everything okay out there?
Well, we had an interesting couple of weeks, but we did better than some folks in neighboring states. So, we'll always be grateful for what we have.
Fantastic. Well, I'm glad that you are doing okay. I do have a friend in Western North Carolina who she was without power for probably about a week and a half. So yeah, glad that you are doing all right. All right, let's talk about this book.
Let's do it.
It's interesting. So I guess the place I want to start with is what makes this different from other astronomy books that are out there. So what was your angle on this particular book to set it apart?
One of the things I really wanted to do with this book, and I think, the jury is out on whether I accomplished it, but I really wanted to take a look as a scientist at the boundaries of knowledge, right? What we know, what we don't know, what we may never know. And so it's not a book so much about things that we know, right? Although there are certainly things that we know that are in the book, but it's really a book that's intended to invite a reader into a place of sort of existential curiosity. And that curiosity really lives at a nexus of, yes, science and empirical inquiry, but also philosophy and theology. Because when we hit the boundaries of what science can tell us, we've hit the boundaries of what science can tell us, and we have to lean into some other disciplines to make progress. So I really tried to write this book with an eye toward different epistemological perspectives on how we look at the universe.
It's kind of a timely thing. So just this morning, we announced a postdoctoral fellowship, and in the list of things that we're interested in is epistemology. So we really are wanting to talk about some of these bigger picture, issues. Some of what you kind of mentioned in here is what caused the Big Bang, which sometimes I hear from people as what was before the Big Bang. If there was nothing, then how did the Big Bang happen? And it's a lot of questions that I think sort of are not necessarily testable, which is why they hit that, not just that we don't understand them, but they hit that border of science, like what we can explain as scientists, and get right up against that wall of, we can try and explain a lot of these things, but we can't test them at this point anymore. We don't have the means or the methods or, the thing. So for you, what was sort of the most interesting sort of one of these walls you found yourself up against, scientifically speaking?
Well, you've already brought it up. The biggest existential question for me that literally gives me insomnia, right? I think more nights than not, I fall asleep thinking about where the universe came from and how we could have something from nothing and what nothing even means. And so that for me is like the grandmother question of them all. And there are so many others like that, though, that I've put in this book that I think call us as scientists, right? Yes, I'm a scientist and I believe in empirical inquiry, but they call on us to have some intellectual humility and acknowledge where we have traction in science and where we don't. And when we don't have traction in science, what options are on the table? and which of those options are consistent with our current understanding of the universe and which aren't, and how do we know? So the biggest question for me, always the one that keeps me up at night, is what caused the Big Bang, or where did the universe come from, I think is how I would phrase it. But all of the questions in this book, they're things that I think of them as like dorm room late night conversations that as a young adult you used to get to have with your friends all the time. And then somehow as you progress as an astrophysicist in the profession, we kind of stop having them. And so I wanted to take this point, firmly in middle age and solid in my career, to say, hey, what if we actually talk about these questions that we talked about so much when we were younger? And I would say, these big existential questions are the reason why so many people are interested in astronomy and the universe. So let's talk about them.
And you definitely do. Straight up, like chapter 4. I love, so if you're wondering what the chapters are in this book, they're all questions like this. But chapter 4, of course, a little bit interesting to those of us who work here. Does extraterrestrial life exist? Right. And I mean, there is a possibility that we can answer this. But it's really interesting that you put it in the book as something that is right up right now against that edge of scientific knowledge. Do you have an answer? Does it exist? Does it not? Is there one way or the other on this question?
I love that you think I might have an answer. I don't have an answer to any of the big questions in this book. All I try to do is give people a framework on how you might think about it. I have my own inklings as a person who thinks about this, right? As I'm sure everyone at the SETI Institute does. But extraterrestrial life is huge. And that is one of the questions in the book that I think may be solvable in our lifetime. Right. There are a few questions like that may actually be solvable. Some of them may never be solvable, but some of them may be solvable. And I would argue, when you look at our current technological capabilities and what we're now able to do, looking at, for example, the composition of atmospheres and exoplanets, and starting to look for things that may be signatures of some kind of biology, right? I really feel like we are on the cusp of answering this at some level. So I'm not a betting person, I'm looking around for something I could bet. I don't even have like a can of Coke or something, but I would bet that within our lifetimes, assuming we don't get hit by a bus tomorrow, we're going to make progress on this, and we're going to have some real information.
So Seth Shostak loves to bet a cup of coffee. That's his favorite. Is that he'll buy someone.
I've got my cup here.
But so yeah, I mean, I do think that just in our brief lifetimes, scientifically speaking, we have made huge advances in this topic. Like you said, when I was younger, we didn't know that there were planets around other stars, right? That was something we thought was possible, didn't know that it was true. And it was only about the time I graduated from high school that became a certainty. And then it's only been in the last 15 years since I really went into the field that it went from a yes, we know there are planets, to, oh my gosh, the planets, there are so many. And now we have JWST, which is telling us that, there's atmospheres around these exoplanets, and we can tell you what they're made of. And so it's the level of the science is amazing that we've gone to. And so yes, there are definitely, when I look at the chapter titles, there are definitely questions in here that I think, we can answer. What are dark matter and dark energy? That's a fun one. Not what we think they are usually. What happens inside black holes? Maybe something we can answer. But then you get into like, are there hidden dimensions? How do we, what is there any method that this can be tested for? And if not, what are some of the more philosophical processes that you're walking through to talk about these?
Well, dimensions is a great example, because, I think a lot of people, when they start hearing about hidden dimensions, immediately their brains go to science fiction, totally unrealistic, crazy idea. And I get that, right? I totally get that. But I think it's really important for us to take a step back and ask what if, and then after we ask what if, ask how we could test it. And it turns out there are actual ways that extra hidden dimensions could manifest in testable ways. And there are actually tests that are currently being done. We can look at, for example, there are some tests that are being used to look at gravitational wave signatures, which at the moment look like they're ruling out certain versions of macroscopic extra dimensions. But some of these things do sort of edge right up against empirical inquiry. And it could be with things like extra dimensions that seem like, they must be totally out of our reach to test empirically. And maybe that's true. But as we think more creatively and as we come up with new tools and techniques and, technologies to do things, I don't want to be the person who ever said something was impossible just because I wasn't creative enough.
I struggle with that a lot. It definitely impacted sort of how I approached science when I was in school. Was, everybody says, oh, think of questions that you don't know the answers to. And my problem was that, well, I know the answer to that. I know the answer to that. That's pretty easy to figure out. And so I just really struggle with sort of thinking outside the box and beyond those boundaries. How did you come up with your list of questions? Was it easy for you? Did you have to outsource some of this to other people, or were these like the whole idea of how did the Big Bang happen? Were they just in your head, sort of sitting there waiting for you to think about them a little bit more deeply?
I think there are a lot of things in my head sitting there waiting for me to think about them more deeply. I will say that for sure. I mean, they're truly the things that they're all things that keep me up at night. And they're things that I find, this might sound silly, but I find joy in thinking about them. And a lot of folks will say, especially scientists will argue, well, what's the point of thinking about this particular question if it may never be answerable? And I just feel like that's not framed in the right way. I think that curiosity in and of itself has value. And just because we might not be able to answer something doesn't mean that we shouldn't. But then the other trick I will say is I've been, I'm a university professor and I've been teaching in the classroom for, well, more years than I'm going to share right now. But, one of the things I've learned over time is there are topics that students really get excited about because they want to know the answers to, right? They're curious. And, as an astrophysicist, I will say, yes, of course, we need to learn about stellar evolution. But does your average introductory astronomy course really need to teach stellar evolution? Like, are students really going to use that skill later in their life? And maybe they will. I would love to hear stories of how someone who took, an introductory astronomy class used stellar evolution later in their life if they're not an astronomer. But for me, what's more valuable as a teacher is finding ways to engage with my students' curiosity and using that curiosity as a vehicle to then ask questions and think about critical thinking and think about what it means for science. And so these are the questions that over time, not only do I feel a real sense of curiosity about, but I've also found, my students feel curiosity about. And then by extrapolation, I could be totally wrong. I extrapolate that probably more people also feel really curious about and maybe want to hear something about from, a professional astrophysicist and not just, pseudoscience on the web.
Right. That's a really good distinction to have. I'm going to welcome in people who are watching. So far, you guys are being a little bit quiet. Talk to me some more. We have New Hampshire, South Carolina, United Kingdom, Texas. So welcome in, everybody. Thank you for joining us. Someone's watching from Earth. Much appreciated. If you're not from Earth, we'd love to know that as well.
We would love to know that. Yes.
Yes, exactly. But in the meantime, so I'm kind of curious, since this does sort of come at astrophysics from a little bit of a different perspective, how easy was it to pitch this book? How difficult was it to pitch this book and have someone go, okay, yeah, we can market, have an audience for that? How did that work for you?
Oh, what a fun question. So, so it turns out pitching this book was probably easier than it should have been. And I feel almost embarrassed admitting that. But, my agent introduced me to a really, truly amazing science editor, probably one of the best science trade book editors in the world. And we had this fantastic conversation. And he, the science editor, the acquisition editor, and the senior editor really felt like this area that's really the confluence of science and philosophy and theology is really underrepresented in the books that are out there right now, right? There are lots of books, lots and lots and lots of books, and I have a lot of them on my shelf behind me and at home, and I read them and I love them as much as anyone. But there are lots and lots and lots of books about what we do know. And those are great, right? We need to have a base of knowledge for anything that we do, but there aren't that many books about what we don't know, right? Because it does seem a little bit oxymoronic to talk about. When I was first pitching, I teach a course on this material. I teach a couple of courses on this material. One of them is called Unsolved Mysteries in the Universe. And I got a lot of flack from my colleagues about this, right? They were like, how are you going to teach this material? What are you going to have on the exam? Are you going to say like, don't solve the Big Bang? But it turns out there's a lot you can talk about in terms of framing how we get to the part that's unsolved and what do we do when we get to that boundary, when we can't go any further, and what are the options on the table. So my editor actually, it was super easy, and they were like, we love this. This is an area we think people will love because they're thirsty, right? They have a hunger and a thirst to hear about topics like this. So maybe they were wrong, and maybe I was wrong, and maybe no one will buy the book, but it was still a joy to write and to surface some of these things I've been thinking about for a long time.
Did you find that you questioned things that you knew, like things that you were certain of while you were writing the book? Did anything come up where you thought, oh, I was under the impression, or like what the science said was this, but in looking at this a little bit more closely, maybe not?
I think that I'm always open to that. I'm trying to think of maybe some specific examples that will illuminate this. But in general, my mindset as a scientist is that I always have to be open to being wrong because that's how we make progress.
Right.
And that's really hard though, right? Because we have confirmation bias and we want to hold on to things that we believe to be true and dismiss information that doesn't agree with those. And so one of the things I've just become really acutely aware when I feel my confirmation bias sneaking in, and I try to call myself on it because there are things about the universe or the cosmos that I want to be true. And so I have to catch myself from like being overly, I think, leaning overly toward those as solutions just because I want them to be true. And so that's something I've just become really aware of. And I would love everyone to be as aware of, or even more aware of than I am, because it's also really annoying to always be questioning yourself.
Fair enough. I'm going to welcome in. Let's see, we got some people watching from Amsterdam, the Czech Republic, more from Texas and England. So thank you, everybody. And Australia. Oh, I'm sorry, Chad. I have your question there. I just didn't. Yeah, I'm having it's Monday, people. It's Monday.
It is Monday, isn't it? At least on Earth.
At least on Earth. So one of the things that I'm noticing just in some of the comments and questions that are coming up, like I could ask you these questions, but I mean, honestly, everybody, read the book. The questions you're asking are in here. Whether or not she has an answer, that's a different story. Sorry about that. But the questions are, it looks like, and I have to say this is very true in my case too, but it does look like they're this sort of, everybody has the same questions. They're looking at the same things. What matter existed before the Big Bang? If everything was there but nothing was there, where did it come from? What is, how is the universe? I think is kind of the big thing, is like, why is the universe? It sort of goes back to the whole idea of, where did all of this come from? How did it start? Because, we know we're here. I can reach out, I can touch things in my room. I know this stuff exists. But when you start to lean back into that origin story, the harder you lean into the origin story, the more difficult it gets to sort of wrap your head around. So I do have to say that as far as our audience goes, I think a lot of the same questions are coming up that you cover in the book. So I do think that you have touched on something in the cultural zeitgeist that will hopefully drive your book sales. Again, this lovely book, everybody, is now out.
So I wanted to say something really quick on this, right? Yes,
Sure.
book sales would be great, but I didn't write this book, and I think many authors don't write books like this to sell them. I wrote it because I want people to read it, right? These are things that I think are just really valuable for us to know as we think about the universe. And so, yes, of course, buy my book. That would be great. But I'm also happy if you borrow it or check it out from a library or, whatever that might be, because I really just want people to read it. But I would love to nerd out with people about the beginning of the universe if people want to take that direction, because that is my favorite topic.
Good to hear. Let's see. We've got people from Denver, so Colorado, my hometown, and Germany. Wow, welcome in. So we've got some. We're getting a lot of Europe going here. So thank you everybody for joining us again. Do you have any answers? Are there any answers you can give us?
Well, I can give some interesting pieces of knowledge, right?
Okay.
So one, I will say, when we talk about where the universe came from, we immediately get into what we call infinite regression, right? Because even if I could tell you that Bob caused the beginning of the universe, then you might say, well, where did Bob come from? Right. And so we quickly go down this trail of infinite regression. And we can talk about that. It is its own philosophical knot to be untangled. But there are a couple really interesting things about the universe. One, I want to point out is that when we look at the observable universe, it actually has a net worth of 0. And what I mean by that is, let's say you want to buy a car, but you don't have any money, and you have a really good friend who's willing to lend you the money interest-free. So you go out and you buy a car. And now you have the car, but you also owe your friend exactly that same amount of money. In some real sense, your net worth is 0. And the universe is actually in a similar position. When we look at the observable universe around us, and we look at all the mass energy, which has a positive value, and we look at all of the gravitational potential energy that has a negative value, as far as we can tell, the net worth of the universe appears to be pretty close to 0, or as close to 0 as we can estimate. And so in some sense, the universe is consistent with nothing, except the question kind of becomes like, well, what was the framework for the loan? Like, what enabled any of this to happen to begin with? And that then gets us talking about, and this is a really fun thing. When I teach this, I teach a whole class on this. And I know that there are students who think I'm crazy, and maybe they're right, but I teach a whole class on different types of nothing, because it turns out there are actually different types of nothing. And if you're going to talk about how we have something instead of nothing, we have to be really precise about what we mean by nothing. And there's a difference between, so sort of having a universe that just doesn't have any particles or force fields or anything like that, and not having, space and time as a framework, and not even having the laws of physics, right? The laws of physics, in some sense, are a thing, right? They're an abstract thing, but they are a thing. And so we really have to be careful about what we mean when we talk about nothing. But even then, as we keep dialing nothingness up more and more and more to truly pure nothing, we don't get out of the problem. We still have to figure out why we have something instead of nothing. And I don't have an answer for that, but I do like to think about what the possible answers might be, and in the future, how we might approach those as humans trying to figure out our place in the universe.
I have a feeling I'm going to be one of those people who's up at night thinking about this now. So thanks for that.
Yay!
I do. Oh my gosh. Okay. I think my brain just broke a little bit there.
No. Your brain is just expanding, right? It's not breaking, it's expanding. And that's what we want. The teacher in me is overjoyed that you're feeling this sense.
I'm gonna share let's see, I'm gonna put this up in the chat for some of people, the link to the book. So you should be able to see that. Uh, and oh God, you have broken my brain. I just want to think about these questions now, and the audience
See, so
isn't
then you
helping
need to
because
write a book on them,
I
right?
know. Well, the audience is asking, things like, did the Big Bang create space, or was space already there? See, like it's as you said, it's a it's a rabbit hole within a rabbit hole within a
Mhm.
rabbit hole. Oh my gosh. Okay. Moving
I'm there for
on.
it.
I we're gonna have to have you back because obviously this needs to be like talked about. Um, Broken Symmetry is asking, what hard to answer questions did you leave out that you didn't have space for in this book, but that you might
Ooh.
want to include in, say, another book?
Oh, also love Broken Symmetry as a call name. That is brilliant. Because it's super apropos because one of the things I am absolutely fascinated by and didn't have time to get into in this book and the level I would like. I mentioned it a few times, but is the nature of symmetry in the universe and where the symmetry comes from and how that relates to, if it relates to, or how it relates to, in some sense, math being the underlying language that the universe is written in. But I think there's a lot to be thought about in terms of symmetry. And one of the things that I think is really dumbfoundingly remarkable about the universe, but also I think completely underappreciated, is that the universe is this really incredible balance between things having symmetries at some level, but also having chaotic structures. And it's a balance between the two. And all you have to do is go out and look at a tree, right? To see this play
Mhm.
out. Like leaves in general have roughly symmetric structure, but they're not perfect, right? They have sort of, I don't want to call them defects because I don't think they're defects. I think they're beautiful variations, right? But the universe need not have been this delicate balance between things having perfect symmetries or things being totally chaotic. And if it had been one way or the other, right? If the universe had been perfectly symmetric, then nothing interesting would ever happen. And nothing interesting would exist. And in fact, the only way to have perfect symmetry in every respect is for there to be nothing. And on the other hand, if the universe were entirely sort of random and chaotic, then it would be unmanageable and unpredictable, and nothing we could get our heads around scientifically would happen. And yet here we are in a universe that has a balance between these two, and I think that balance is completely fascinating and captivating, and I would love to write a whole book on that. So Broken Symmetry, I love your name, and I'm spot on with that, and I might try to steal the name.
Well,
Maybe it'll be the name of the book.
there you go. There you go. And they're quite thrilled that you're going to write a book about them. So, oh my gosh.
We'll see what my editor thinks.
So what is next for you? What are you working on now? You're still teaching. You're still living your everyday life. Obviously, are you working on? Do you have another book already planned out? I still don't understand how people do that. It amazes me. Or is there scientific research that you're working on? What's going on for you in the near future?
All of those things, right? All of those things. So it's, I think like everyone, there's not enough hours in the day to do all the things we want to do. And I have, when I first met my agent a couple of years ago, I pitched to him, I think probably roughly 10 different book topics that I wanted to write books on. And we decided together what the first book should be. And that's this book. And, we'll see how this book goes. And if it's a success, maybe that will lead to a second book. But I have at least 9 other book ideas waiting there for me to dive in and flesh out. And I will say one of the things, maybe I came too late in life as a scientist, but I love writing. I just love it. I get into a zone and like a flow state where just time goes by. I don't even realize I'm hungry, which for me is a gift because I love food. Uh, so I'm really looking forward to figuring out what that next book is. And if the listeners have ideas on what they would like to hear, like to see a book on, I'm all ears because I've got to make some decisions because there's only so many only so many hours in a day and only so many days in a year and only so many years left in my life. So I've got to prioritize what I do.
Well, I think that you are on the right track, because this is truly fascinating, and I'm excited to dig further into it even. Thank you for being here today. I'm fascinated, and you've broken my mind, and now I have to go play with some things that will be fun. Like this book, but I'm going to be up all night. I can just tell. Between you and Katie Mack, like, yours is sort of the how did the universe start, and hers is how will the universe end. And now I just sit here going, oh my gosh, how did we end up in the middle of it? Is the question. And then you realize that you're just like a walking, talking sack of signatures and chemical soup that is conscious.
Yeah. But you know what? Let's pause though. Let's pause and appreciate that, because yes, in some ways we're just like, collections of molecules that happen to be sentient, which itself is pretty remarkable. But we're living in the universe right now, which is an amazing, remarkable time. And I worry sometimes that we, with our short human lifespans, we don't really appreciate the magnitude and the grandeur of the universe that we're living in. So take a moment and pause and think about how lucky we are to be here.
Absolutely. That is a very good point. And we are. I am lucky to do what I do. I am lucky to get to speak to amazing scientists and writers like yourself. So, it definitely puts things in a very good perspective, I think, to sort of understand that, yes, this is wild and amazing, but the amazing is the part that we should focus in on. All right. Well,
and let's not waste our time. Let's do good things.
Exactly. It is never too late to do good things. Absolutely. All right. Well, everybody, thank you for joining. Kelsey, thank you for being here today. So appreciated that you took the time.
Such a pleasure.
Really glad to have you. And once again, because I am doing this to help hype her book, Into the Unknown, is on sale now. And you can find that at booksellers, whatever your choice is. I will always recommend bookshop.org to find a local bookseller to yourself. Request a copy for your library so that other people can enjoy science. That's what I have to say there. We are the SETI Institute. We are a nonprofit 501c3 organization. We get to do this because of generous donations from our viewers. So thank you. If you've made a donation, if you've given stars or bits or subs or super chats, those are all very helpful. They let me continue to talk to amazing people like Dr. Johnson. And, then I can continue bringing all of these great works to you. I will be back on Thursday. I'm going to be talking way too early in the morning to Peter Michel about the Hera mission. So join me then. It's going to be at 9 a.m. Pacific time. I don't know how I'm going to do this. We all know I'm not a morning person, but we're going to try. And if you are interested in supporting us, you can always go to SETI.org and click the bright red Donate Give Now button. And thank you, everybody, for joining us. And we'll see you later on this week. And thank you, Dr. Johnson, once again.
So fun. Goodbye, everyone.